Using indigenous design to explore contemporary ideas in quantum mechanics. Mark Chavez, presenting, Media Art Nexus Studios, Singapore, Ina Conradi, Nanyang Technological University, Singapore. In this paper, we explore the potential of animation to explain complex scientific concepts through cultural design archetypes. Specifically, we present two case studies in animated films, Quantum Logos, Vision Serpent, and Muarai, Thread of Life, which utilize Mesoamerican and Southeast Asian cultural motifs to represent key aspects of quantum theory and string theory. The artworks described our attempt to represent key aspects of quantum mechanics and string theory and draw upon Gian Baudrillard simulacra and simulation to discuss abstract animated imagery in the context of art and science representations that use archetypal visual design. In taking this approach, we wish to highlight the illusory nature of reality in contemporary society while contrasting these societal perceptions with realities explored when examining the beauty of quantum mechanics. There are no direct connections between these areas of study. Our research uses metaphors derived from both to describe our artistic goals and inspiration. Quantum Logos, Vision Serpent. Going beyond the limitations of classical logic, this film uses images as poetry to represent the quantum world. Using cultural icons to create visual metaphors to explore and discover, communicating the counterintuitive and contradictory beauty of quantum physics. Muarai, Thread of Life. Set in the distant future, a female astronaut searching untouched lands finds herself gravitating toward a mysterious force in a strange cave. The viewer follows her through a journey of discovery and understanding as she gets pulled into another dimension, her self entwined and connected with the larger fabric of the universe. The Muarai were the white-robed incarnations of destiny who controlled every mortal's metaphorical thread of life from birth to death. In this film, we reinterpret this metaphor to describe quantum phenomena. This film uses intuitively derived design metaphors to explain quantum theories. Southeast Asian fabrics serve as the film's primary inspiration. Our case studies use design archetypes inspired by ancient cultural art and storytelling. The films provide visual metaphors that help to explain complex concepts in a more accessible and engaging way. Design elements that resonate with audiences on a cultural level enable the films to visualize scientific ideas more intuitively and relevantly. Our case studies focus on two core issues in quantum theory. This research highlights the importance of using new creative technologies to construct designs that demonstrate similarities between current scientific notions and ancient indigenous thought. By doing so, we emphasize the blurred boundaries between reality and representation and reveal the interconnectivity between scientific observations on the nature of reality and intuitive, artistic expression. Offering fresh insights into quantum theory, we attempt to underscore the value of incorporating diverse cultural perspectives in the production of scientific media. Ultimately, this paper argues that animation can be a powerful tool for decolonizing science communication by foregrounding subjective experience and utilizing cultural design archetypes to enrich scientific storytelling. Archetypes in design and art are recurring patterns or symbols with cultural significance derived from observations of nature and resultant philosophy. These archetypes are used as inspiration in creating visual elements in our films. Drawing from these archetypes, the films incorporate familiar and recognizable symbols that resonate with the audience. The purpose of employing these archetypes is to enhance the understanding and communication of complex concepts. Scientific ideas can often be difficult for people to grasp due to their abstract nature or technical language. By using visual metaphors rooted in ancient art and philosophy, the films provide a more accessible way to convey these ideas. This approach allows the audience to engage with the material on a deeper level, as they can draw upon their own cultural knowledge and experiences to understand better the concepts being presented. About 2 years ago, we began exploring generative AI in art. We looked into using it for visual development on our current film Warai, Thread of Life. We are interested in how we can use machine learning techniques to create art and animation. Baudrillard's simulacra and simulation concept refers to the blurring of the boundary between reality and representation in contemporary society. In his theory, he argues that society has become so saturated with media images and representations that it becomes difficult to distinguish between reality and simulation. He suggests that the signifiers or representations of reality have become more important than the reality itself. Baudrillard's ideas can be applied to the representation of animated physical reality in animation. Animation is not a direct representation of reality but a simulation of it. It is a constructed world that mimics reality but not in the traditional sense. The use of animation allows for the creation of alternative worlds and abstract concepts, which may be difficult to represent in traditional visual media. Using animation, the boundaries between reality and representation are blurred, and the viewer's perception of reality is challenged. Similarly, Sergei Eisenstein's writings on animation suggest that animated images can resist Western rationalism and binary thinking. In Eisenstein's view, animated figures have a plasmatic elasticity and can change shape, species, gender, or any other imposed boundary. In this sense, animation has the potential to represent physical reality in a way that transcends the limitations of traditional media, and it can provide a new perspective on the world. Taken together, Baudrillard's and Eisenstein's ideas highlight the potential of animation to represent physical reality in a way that challenges traditional notions of representation. Using animation, we can create new realities that blur the boundaries between reality and representation and provide new perspectives on the world. In Quantum Logos, Vision Serpent, we illuminate quantum mechanics with the visuals and related ideas derived from mythic archetypes. In the film, our challenge was to find a way to convey meaning with an aesthetic approach toward abstract and invisible knowledge by comparing the phenomenological aspect of quantum mechanics with ancient artistic design archetypes. The patterns identified are, like mandalas, attractive to the aesthetic eye. Yet share design similarities with mathematical patterns observed in quantum mechanics. By utilizing intuitive forms with significant meaning for less technically informed early cultures, we found that many visualizations made by early cultures shared common design traits with graphically represented math in contemporary quantum physics. Ernst Chladni, 1756–1827, the father of acoustics, found a simple relationship between sand and various vibration modes on a smooth surface. On polished steel plates, he dusted fine sand and created patterns of nodal lines with the subtle vibrations of a violin bow. The audible vibrations caused by the violin bow stroking the side of the metal plate formed patterns, while the sand formed linear patterns corresponding to the audio waveform. A step-by-step explanation of how Chladni plates work to visualize sound. Excitation: the Chladni plate is mounted securely and horizontally. A sound source is used to create vibrations in the plate. The bow is drawn along the edge of the plate, causing it to oscillate and produce sound waves. Nodal lines: as the plate vibrates, areas of maximum and minimum displacement, called nodal lines, start to form. Nodal lines are regions of the plate that remain stationary while the rest vibrates. These lines represent points of destructive interference, where the sound waves cancel each other out. Antinodes, in contrast to nodal lines, areas of maximum displacement, called antinodes, also develop on the plate. Antinodes are regions where the vibrational motion of the plate is at its maximum. These areas represent points of constructive interference, where sound waves reinforce each other. Resonant frequencies. The pattern formed on the Chladni plate depends on the frequency of the sound produced and the vibrational modes of the plate. Each shape corresponds to a resonant frequency, which is a natural frequency at which the plate tends to vibrate. Different modes of vibration produce different patterns. Fine powder. To make the nodal lines and antinodes more visible, a fine powder, such as sand or salt, is evenly spread across the surface of the plate. The powder accumulates along the nodal lines due to the lack of motion in those regions. At the same time, the powder is cleared away from the areas of maximum motion, the antinodes, resulting in a distinct pattern. Visualization. As the plate continues to vibrate, the powder forms intricate and beautiful patterns that correspond to the vibrational modes of the plate. These patterns can vary widely, ranging from simple symmetric shapes to complex, intricate designs, depending on the frequency and mode of vibration. Using insights offered by Chladni plates, we can gaze into the nature of sound waves and study the relationship between frequency, vibration, and resonance. The phenomena offer a visual representation of sound that helps deepen our understanding of acoustics and the fundamental properties of waves. Audio-generated visual patterns create beautiful geometric figures with sound in many areas of nature, such as in snowflakes and even in the colossal weather systems on Saturn. The tortoiseshell and other natural designs also resemble patterns generated by cymatics techniques at specific frequencies. Cymatics is a subset of modal vibrational phenomena. Cymatics is a subset of modal vibrational phenomena. Modal vibrational phenomena encompass a broader range of phenomena involving the vibrational modes of physical structures, while cymatics specifically focuses on the study of visible patterns created by sound waves vibrating physical materials. Modal vibrations refer to the characteristic vibrational modes of a system or structure, the natural frequencies at which the system vibrates when excited. These modes are determined by factors such as the structure's shape, size, and material properties. When the structure is excited at one of its natural frequencies, it vibrates in a specific mode, producing standing waves or patterns. As a branch of modal vibrational phenomena, cymatics specifically explores the relationship between sound waves and the resulting visible patterns or forms created in physical materials. By applying specific frequencies to a medium, such as a liquid or a solid surface, cymatics allows us to observe and study the intricate patterns and shapes that emerge due to the interaction between sound waves and the material. Our artistic approach, the ideology of meaning, revolves around moving away from fixed, objective interpretations and recognizing interpretation's subjective and contingent nature. We reject the idea that there is a universal truth or meaning that can be objectively derived from an artwork. Our artistic practice embraces the multitude of meanings and interpretations that arise, acknowledging that meaning is constructed through a complex interplay of cultural, historical, social, and individual factors. We employ various strategies, such as fragmentation, pastiche, irony, and parody, to disrupt and question established systems of meaning. By challenging the status quo, we actively reject grand narratives and meta-narratives that claim to provide all-encompassing explanations of reality. Instead, we celebrate the diversity and plurality of voices, perspectives, and interpretations. We understand that meaning is inherently unstable, context-dependent, and subject to constant negotiation and re-evaluation. Overall, our artistic approach defies traditional notions of meaning, inviting viewers to actively engage with our work and participate in the ongoing dialogue that shapes its significance. Our artistic practice dismisses grand narratives and meta-narratives that offer definitive explanations of reality. Instead, we celebrate diversity in the multitude of voices, perspectives, and interpretations. Moreover, we firmly believe that meaning is inherently unstable, context-dependent, and subject to constant negotiation and re-evaluation. In our work, we challenge traditional notions of authorship and originality by emphasizing intertextuality, appropriation, and recycling existing cultural forms. We also question the idea of the autonomous artist genius and recognize the collective and collaborative nature of artistic production. Rather than adhering to fixed meanings, we understand that an artwork is not confined solely to the intentions or inherent qualities of the artwork itself. Instead, meaning is co-constructed through the artworks and the viewer's interactive relationship. Each individual brings unique perspectives, experiences, and cultural contexts, actively contributing to the interpretation process. The overarching ideology that defines our artistic expression embraces plurality, subjectivity, and the ongoing process of interpretation and redefinition. Accordingly, we foster an open-ended and inclusive approach to understanding and engaging with artworks, rejecting rigid meanings in favor of a more fluid and contingent understanding of artistic expression. Through our work, we invite viewers to participate in this dynamic and ever-evolving dialogue, encouraging them to explore and discover their connections and interpretations. By embracing the complexities and uncertainties of meaning, we aim to challenge established conventions and promote a deeper engagement with the diverse possibilities inherent in artistic creation. In conclusion, our artistic practice exemplifies a postmodernist perspective that intricately fuses scientific theories with artistic concepts, significantly contributing to the discourse on decolonizing animation. By rejecting fixed narratives, we actively celebrate the emergence of diverse voices and interpretations, acknowledging the inherent instability of meaning. Inspired by the profound insights of quantum mechanics and string theory, we deeply comprehend reality's intricate complexity and multifaceted nature, which is shaped by dynamic vibrations and interconnected modalities. Utilizing simulacra and simulation as invaluable lenses, we purposefully challenge established conventions, actively exploring the fluidity of representation and perception within the context of decolonization. Within our artistic endeavors, meaning is co-constructed, and the interaction between our artwork and the viewer becomes a transformative process intricately influenced by their individual perspectives, experiences, and cultural contexts. By skillfully interweaving these profound philosophical, scientific, and artistic elements, we extend a fervent invitation to esteemed conference attendees to engage in an inclusive and open-ended exploration, ultimately illuminating the boundless possibilities intricately woven within the realm of decolonized animation.